In 1880, a boy wading through ankle-deep water in a narrow channel beneath the oldest part of Jerusalem lost his footing and fell. When he stood up, his hand brushed the tunnel wall at shoulder height, and he felt something that did not belong to the natural texture of cut limestone. He moved his fingers across it again. Letters. 6 lines of ancient Hebrew, carved directly into the rock face at the precise point where 27 centuries earlier, 2 teams of workers cutting from opposite ends of a 533-meter tunnel had broken through to each other in the dark. That inscription, now housed in the Istanbul Archaeological Museum after its removal by Ottoman authorities in 1890, is the oldest known construction completion report in the Hebrew language. It does not mention God. It does not praise a king. It does not dedicate the tunnel to any deity or political authority. It describes, in the first-person plural, the operational moment of breakthrough, the sound of voices carrying through the remaining rock, the final course correction, the water rushing through the gap. A work crew documenting the end of a project. And the project they documented is the reason Jerusalem survived the most efficient military machine the ancient Near East had ever produced. Here is what the inscription does not tell you, and what the tunnel itself does. The hydraulic gradient across those 533 meters is 30 centimeters. Total drop. From the Gihon Spring on the eastern slope of the city of David to the Pool of Siloam at the southern end inside the walls. Now the water descends less than 1/3 of a meter across a distance longer than 5 American football fields, laid end to end. That gradient produces a flow velocity of approximately 0.3 meters per second, enough to deliver roughly 1,500 liters per hour to the receiving pool, enough to keep 25,000 people alive behind sealed walls while the largest army in the known world camped outside and waited for thirst to open the gates. The gradient was maintained to millimeter-level tolerances across the entire length, in total darkness with no optical surveying instruments, using water itself as the only reliable level, a technique documented in ancient Near Eastern construction and still used in modern field engineering when electronic instruments are unavailable. Not prayer, gradient. And the story of how that gradient was cut through solid Meleki limestone with copper chisels and iron picks by 2 teams who could not see each other, could not communicate except through the rock between them, and had approximately 3 to 4 weeks before the Assyrian siege perimeter closed around the city. That story is not a parable. It is an engineering case study, and every datum in it is still physically present, still measurable, still flowing, 533 meters beneath the streets of modern Jerusalem. The Siloam inscription is 6 lines long. In archaeological terms, it is classified as a monumental inscription, but that classification is misleading. Monumental inscriptions in the ancient Near East served political and religious functions. They announced victories, dedicated temples, recorded the piety of kings. The Siloam inscription does none of these things. Its language is technical. Its subject is a construction event. Its authors refer to themselves only as the tunnelers, the men who cut, and the content of their report is confined entirely to the operational details of the final excavation phase. 2 teams approaching each other from opposite ends, the sound of the other team's work through the remaining rock, the adjustment of cutting direction based on that sound, the moment of breakthrough, the water flowing from the spring to the pool through the completed channel. What the inscription documents is a navigational methodology. The 2 teams were not cutting blind, they were cutting by ear, and the physical properties of the rock they were cutting through are what made that possible. Melek limestone, the specific geological formation that constitutes the bedrock beneath the city of David, has a density of approximately 2,160 kilograms per cubic meter. At that density, the acoustic transmission velocity through the stone is approximately 6,000 meters per second. Sound generated by an iron pick striking stone at one cutting face would propagate through the solid rock and arrive at the other team's face in under 1/10 of a second, regardless of the intervening distance. At 250 meters of separation, the approximate midpoint distance when both teams were actively cutting, the transmitted sound arrived with sufficient amplitude and directional clarity for an experienced stonecutter to determine not only that the other team was working, but approximately where within the rock face their strikes were originating. This is not speculation, it is acoustics. And the physical evidence of its application is carved into the geometry of the tunnel itself. The tunnel does not follow a straight line between the Gihon Spring and the Pool of Siloam. If it did, the distance would be approximately 320 meters. Instead, the tunnel traces a pronounced S-curve that adds over 200 meters to its total length. For decades, this deviation was interpreted variously as a route chosen to avoid royal tombs, as a consequence of following a natural water channel, as evidence of poor navigation. None of these explanations account for the totality of the evidence. The S-curve, when mapped against the documented ceiling height variations along the tunnel's length, reveals a pattern that is now understood to represent real-time navigational corrections. At specific points along the curve, the ceiling height changes abruptly, not because the rock formation changes, but because the cutting team adjusted their vertical angle in response to new acoustic information about the position of the approaching team. The deviations are not errors. They are course corrections. They are the physical record of two groups of men navigating toward each other through solid rock by listening. To understand why this tunnel exists, you have to understand what Sennacherib had already done by the time Hezekiah ordered the cutting to begin. The year is 701 BCE. Sennacherib, king of Assyria, has launched a military campaign against the rebellious vassal states of the Levant. So, the campaign is not speculative. It is documented in extraordinary detail on the Sennacherib prism, a hexagonal clay cylinder now in the Oriental Institute at the University of Chicago, which records the campaign in the king's own commissioned account. The document states, in Akkadian cuneiform, that Sennacherib conquered 46 fortified cities in the kingdom of Judah and deported their populations. Archaeological evidence at Lachish, Judah's second largest city, confirms the Assyrian account. The siege ramp is still visible. The arrowheads and sling stones are still embedded in the destruction layer, and the mass grave of defenders is still catalogued in excavation records spanning the 1930s through the 2000s. Lachish fell. Every fortified city between the coastal plain and Jerusalem fell. The Assyrian army moved methodically, city by city, toward the capital, and everyone inside the capital walls knew it. Hezekiah had intelligence of this progression. The fall of each city was not a secret. It was a message. The Assyrian military doctrine of the 8th and 7th centuries BCE relied on the visible, documented destruction of resistance as a psychological weapon against the next target. The wall reliefs from Sennacherib's palace at Nineveh, now in the British Museum, depict the siege of Lachish in graphic detail. Defenders impaled on stakes outside the walls, civilians marched into exile in long columns, the city burning behind them. These reliefs were carved for a domestic audience in Nineveh, but their content was known throughout the region. Everyone in Jerusalem knew what had happened to Lachish. Everyone in Jerusalem knew they were next. The military problem was not complex. It was binary. Jerusalem sat on a ridge with natural defensive advantages, steep valleys on 3 sides, that made direct assault costly. The Assyrians understood this. Their preferred strategy for well-positioned cities was siege. Establish a perimeter, cut supply lines, wait, A city without external water access could hold for 3 to 5 days in the summer climate of the Judean highlands before dehydration began to degrade the defensive garrison's capability. Within 2 weeks, organized resistance would collapse. The Gihon Spring, Jerusalem's primary and most reliable water source, emerged from a cave on the eastern slope of the city, outside the fortification walls. Any competent siege commander would identify it within hours and either seize it or block it. Either way, Jerusalem's survival clock started the moment the Assyrian perimeter closed. Hezekiah's engineering problem was not whether to move the water inside the walls. It was how, and how fast. The straight-line distance between the Gihon Spring and the Pool of Siloam is approximately 320 meters. The rock between them is Melek limestone, cuttable with period tools but not soft. Average cutting rates in comparable limestone with iron tools range from 0.5 to 1.5 meters per day per cutting face, depending on rock hardness, tool condition, ventilation, and lighting. Even at the upper end of that range, so a single cutting team working from one end would require between 7 and 14 months, a timeline measured in seasons, not weeks. The Assyrian campaign timeline gave Jerusalem weeks at most. A single team was not viable. The solution was to cut from both ends simultaneously. 2 teams, one starting at the Gihon Spring and one starting at the planned Pool of Siloam entrance, cutting toward each other. This halved the cutting distance per team to approximately 266 meters. It also introduced the central engineering problem that would define the entire project. The 2 teams had to meet. Not approximately. Not within a margin of several meters that could be corrected later. They had to meet within the width of the tunnel, 60 centimeters at its narrowest point, at the correct depth, at the correct gradient, so with sufficient precision that water would flow from one end to the other by gravity alone the moment the breakthrough occurred. If they missed, if the 2 bores passed each other in the rock, offset by even 2 meters laterally, the project would fail, the water would not flow, and 25,000 people would die of thirst behind walls that the Assyrian army would not need to breach. There were no surveying instruments available in 701 BCE that could guarantee 2 teams cutting from opposite ends of a 533-meter tunnel would meet within the tolerances required. No theodolites, no transits, no optical sighting equipment. The Egyptian technique of surface surveying, running a measured line across the surface terrain and sinking vertical shafts at intervals to establish reference points, may have been partially employed, but the terrain above the tunnel is an occupied urban hillside, and no evidence of intermediate shafts has been found. What was available was acoustics. What was available was the physical property of Melek limestone that transmits sound at 6,000 meters per second, and the knowledge, held by every experienced quarryman in the ancient Near East, that you could hear another team's tools through the rock. The 2 teams began cutting. The northern team started at the Gihon Spring, working south and west. The southern team started at the planned Pool of Siloam terminus, working north and east. Each team worked in a space approximately 60 centimeters wide and between 1 and 5 meters tall, the height variations corresponding to the navigational corrections that would be studied 27 centuries later. The lighting was oil lamps. The ventilation was whatever airflow the tunnel's own geometry provided, supplemented by the natural draft created by the temperature differential between the tunnel interior and the open air at the entrance. The temperature inside the tunnel, even today, is a constant 18 degrees Celsius. Cool enough to prevent heat exhaustion, but the humidity at the cutting face approached saturation as freshly exposed limestone released moisture from its matrix, and human respiration and lamp combustion added water vapor to the enclosed space. Limestone dust from each pick strike hung in the still air, coating the workers' skin and lungs, mixing with lamp smoke to produce a haze that reduced the effective light radius of a single oil lamp to less than 2 meters. Beyond that radius, darkness. Not the darkness of a room with the lights off, the complete absolute absence of photons that exists inside solid rock below ground level. A darkness so total that the visual cortex begins generating phantom patterns. Neural noise the brain interprets as faint light when no light exists. The workers at the face operated in this environment for hours, striking the rock by feel and sound as much as by sight, the lamp behind them throwing their own shadow across the cutting face. The cutting tools left their signatures in the rock. Archaeologists have documented two distinct tool mark patterns: broad, deep grooves consistent with iron picks used for bulk rock removal, and narrower, shallower marks consistent with copper or bronze chisels used for precision work, particularly along the tunnel floor where gradient accuracy was critical. The floor, where the water would flow, shows the most careful workmanship. This is consistent with a team that understood the hydraulic constraint. The gradient had to descend continuously from north to south, with no reversals, no pooling points, no sections where the floor rose above the intended grade line. A reversal of even a few centimeters would create a dead spot where water velocity dropped to zero, halting flow. The floor was the critical control surface. The walls and ceiling needed only to be wide enough and tall enough for workers to operate. The floor had to be right. The technique for maintaining the gradient in total darkness was direct and effective. At intervals during the cutting, water was introduced at the uphill end of the completed section. If the floor grade was correct, the water flowed continuously toward the cutting face. If it pooled or reversed direction, the floor at that point needed correction cuts. Water was the instrument, a direct measurement of the variable that mattered, the hydraulic behavior of the surface, rather than an indirect measurement through surveying geometry. Modern tunnel engineers working without electronic instruments use the identical method. Water does not lie about gradient. It flows downhill or it does not flow at all. As the two teams penetrated deeper into the rock, the navigational challenge intensified. At 50 meters of separation, the acoustic signal from the opposing team's tools was strong, directionally unambiguous. At 100 meters, directional information began to degrade. Sound reflecting off tunnel walls created secondary arrivals that confused the apparent direction. At 200 meters, the signal was faint, the directional information marginal. Designated listeners pressed their bodies against the rock face in total silence. All tools stopped, all workers motionless, waiting for the next strike from the opposing team, extracting directional data from subtle amplitude and timing differences. The inscription describes this phase. The tunnelers record hearing voices, not tools, voices, through the remaining rock as the two teams converged. At 10 to 20 meters of separation, the human voice, which occupies a frequency range of roughly 85 to 300 hertz, transmits through Maleki limestone with enough fidelity to be recognized as speech, even if individual words are not intelligible. The tunnelers were hearing each other talk, and they used that information to make their final navigational corrections, adjusting their cutting direction toward the strongest signal until the wall between them was thin enough to break through. 2 Chronicles, chapter 32, verses 3 and 4, documents a simultaneous operation often overlooked. Hezekiah organized a workforce to block and conceal all water sources outside the walls. The passage is explicit. They blocked all the springs and the stream that flowed through the land, asking why the kings of Assyria should come and find plenty of water. The Gihon Spring's surface outlet was sealed. Smaller springs in the Kidron Valley were blocked. Any watercourse an Assyrian engineering officer could identify and exploit was eliminated from the terrain. This was not a religious act. This was denial of resource doctrine, the deliberate concealment of assets that would benefit an approaching enemy. The tunnel moved the water inside the walls. The concealment operation erased the evidence that the water had been moved. Together, they constituted a complete military water security operation. Supply secured, intelligence denied, executed under active threat conditions with a timeline measured in weeks. And here is what the record documents about the outcome. When the Assyrian army arrived at Jerusalem after destroying 46 cities, after the fall of Lachish, after every strategic calculation pointed toward Jerusalem's capitulation, they found a city with intact walls, a defending garrison showing no signs of water deprivation, and no accessible external water source to seize or contaminate. The Sennacherib prism records the siege. Sennacherib claims to have shut Hezekiah up like a bird in a cage. But the prism does not claim the city fell. It does not describe a breach. It does not record a surrender. Among 46 documented conquests, Jerusalem is the single city where the language shifts from active destruction to passive containment. The army surrounded the city. The city did not fall, the army withdrew. That withdrawal, documented in 2 Kings chapter 19, ended the siege and preserved Jerusalem as the capital of Judah for another century. The tunnel did not win a battle. It made a battle unnecessary. It removed the single variable, water access, that would have forced capitulation on the same timeline as every other city Sennacherib besieged that year. That framework, identify the single point of failure before the crisis arrives, engineer the redundancy while there is still time to build it, conceal the solution from the threat, is not ancient history. It is a decision-making architecture for infrastructure under duress. It applied to a king facing an army in 701 BCE. It applies to a city facing a supply chain disruption today. It applies to anyone who has looked at a critical dependency and asked the only question that matters. What happens when this fails, and what am I building now, before it does, to survive the failure? Check the pinned comment for a complete breakdown of Hezekiah's crisis infrastructure methodology and its documented applications across personal, civic, and organizational resilience planning. The analysis is there. The framework is 2,700 years old and still operational. The chisel marks reveal more than tool types. At the northern end, the Gihon Spring entrance, the marks indicate rapid, aggressive cutting with iron picks, producing deep parallel grooves at a 45-degree angle to the tunnel axis. Maximum material removal per strike, minimal concern for wall finish. The tunnel dimensions in this section are the widest and tallest on the route, a team optimizing for rate of advance. At the southern end, the marks are shallower, more closely spaced, oriented more nearly perpendicular to the axis. The southern team was cutting for precision, maintaining gradient, holding the line, providing the stable reference toward which the faster-moving northern team navigated. This division of roles, one team for speed, one for accuracy, is a documented strategy in dual-heading tunnel construction and represents a sophisticated understanding of the trade-offs involved. By assigning competing demands to separate teams, the project leadership optimized for both simultaneously. The workforce was constrained by the tunnel's dimensions. At 60 centimeters wide, only one cutter could work the face at a time. A second worker stood immediately behind, passing tools and removing cut stone. A third managed the lamp and airflow. Beyond that, the tunnel was a single-file corridor. Cut stone passed hand to hand from face to entrance. The limiting factor was not labor, but the physical constraint of the space itself. The cutting was therefore continuous. 24 hours a day, rotating shifts, every minute at the face counted against a military timeline with no flexibility. The Assyrian army was not going to wait. Behind the northern team, the Gihon Spring pulsed on its cycle. It is a karst spring, a pressurized groundwater outlet discharging in pulses of 15 to 45 minutes. The northern cutters worked to that rhythm, water rising past their feet, then receding. The sound of that water, low, continuous, rising and falling, was the background noise against which acoustic navigation had to function. The listeners at the face had to distinguish transmitted strikes from the spring's ambient noise, from their own team's echoes reverberating in the tunnel behind them, from the geological sounds of thermal stress in the limestone. They were performing signal processing in real time, in total darkness, cheek pressed against cold, damp limestone, extracting a directional signal from a noise field. 25,000 lives depended on their interpretation. The breakthrough happened. The Siloam inscription records it without drama. The last wall of rock was thin enough for voices to pass clearly. The cutters adjusted their final approach. The rock was cut through. The water flowed. The inscription describes it in the language of workers completing a task. The completed tunnel's hydraulic performance has been measured by multiple research teams. The 30-centimeter drop across 533 meters produces a gradient of approximately 0.06%, less than 1 millimeter of fall per meter of distance. Flow velocity calculated using the Manning equation for open-channel flow in rough-hewn limestone is 0.3 meters per second, delivering approximately 1,500 liters per hour. During surge pulses from the spring, the rate increases. Total daily delivery to the Pool of Siloam, averaged across the pulsing cycle, is approximately 36,000 liters, sufficient for a besieged population under military rationing protocols. This gradient precision separates the tunnel from every comparable water conveyance in the ancient Near East. The earlier Siloam Channel ran along the surface and was siege vulnerable. Tunnels at Megiddo, Hazor, and Gezer used steeper gradients, shorter distances, or vertical shafts. None maintained a 0.06% gradient across half a kilometer from two headings navigated by sound. The precision would be considered acceptable in modern civil engineering for a gravity-fed conveyance. The gradient was not an accident. It was the product of continuous monitoring, corrected in real time at the face by workers who understood that the water would not flow if the floor was not right, and the water had to flow. Everything depended on it. The tunnel is still there. It has been open and flowing continuously for 2,725 years. The Gihon Spring still pulses. The water still enters at the northern end, flows through the S-curve, and emerges at the Pool of Siloam. Tourists walk it today in knee-deep water, the full 533 meters in approximately 40 minutes, moving against the current. Their heads brush the ceiling at low points. Their shoulders touch both walls at the narrows. When the flashlights go off, the darkness is so complete that the difference between eyes open and closed is zero. The chisel marks are still visible on the walls. Press your palm flat against the stone and move it slowly. You feel the individual strokes under your fingers, the rhythm of a copper chisel driven by a hammer, the angle of each cut. The slight lateral shift between impacts that tells you the cutter was working left to right across the face. The marks have not been smoothed by erosion because the flow velocity is below the threshold for significant erosion of Melike limestone. The tunnel will carry those marks for millennia yet. The limestone records. It does not forget. The Siloam inscription is in Istanbul. It was cut from the tunnel wall by an unknown party in 1890. During the attempt, the inscription was broken into fragments, later reassembled, and confiscated by Ottoman authorities for transport to the museum where it remains. The text is fully documented and not in dispute. 6 lines of Paleo-Hebrew script describing a construction event, no divine attribution. A work crew recording what they did at the place where they did it. What no inscription records is the decision. Somewhere before the cutting began, Hezekiah received intelligence about the army's progress through Judah. Somewhere the engineering option was presented. 533 meters, solid limestone, 2 teams, acoustic navigation, no certainty of success. A timeline that might not be sufficient. And somewhere in a conversation we cannot reconstruct, the decision was made to start cutting. That decision was made without knowledge that it would work, without a guarantee the 2 teams would meet, without certainty that the army would not arrive first. It was an engineering bet, calculated, analyzed, constrained by the physics of limestone and acoustics and hydraulics, but a bet, because the outcome was not known when the cutting started. It was only known when the cutting finished. The tunnel documents a method. Identify the critical vulnerability before the threat arrives. Design the engineering solution while there is still time to build it. Execute with the best available tools and the best available people at the maximum sustainable rate. Conceal the solution from the adversary, and then wait behind the walls with water flowing beneath your feet through 533 meters of solid rock, while the largest army in the world sits outside and waits for you to die of thirst. And you do not die, because the water is inside the walls, because the gradient is correct, because 2 teams of men cut toward each other through solid limestone in total darkness by listening to each other's voices through the rock, and broke through with a precision that, 2,700 years later, still meets the engineering standard. The tunnel was built. The army came. The water flowed. Jerusalem survived. That is the sequence. And every element in it is still there. The tunnel, the water, the chisel marks, the inscription text, the archaeological record of a siege that did not succeed. Measurable, walkable, legible, flowing. What the tunnel records is not a miracle. It is what happens when the engineering is done before the crisis arrives and the crisis finds nothing left to exploit.